In this video, we'll be talking more about rates of change. Specifically, we'll talk about what an average rate of change is. We'll be learning more about rates of change by looking at a specific example. Suppose that you started a road trip at 12 p.m. You reached your destination at 4 p.m. and had driven 240 miles. The question here asks us, how fast did you drive? From our last video, we learned that speed is a rate. It tells us how distance changes as time changes. And from our previous video, we learned that to calculate speed, we take the distance traveled and we divide it by the amount of time it took. Here, our distance traveled is going to be 240 miles, and the amount of time it took would be 4 hours since we started our trip at 12 p.m. and we got to our destination at 4 p.m. Taking 240 divided by 4, we end up with 60 miles per hour. From experience, you'll know that you're probably not driving 60 miles per hour the whole time. Sometimes you may be going faster, sometimes you may be going slower. You might even be stopped at a stoplight during this road trip. So this 60 miles per hour that we calculated is not how fast we're going at any given time. Instead, it is our average speed. It is how fast we're going on average throughout the road trip. So when we talk about rates of change, we actually have to be more specific. There's the average rate of change, which is what we're calculating here, and also what we calculated in our previous video. And then there's something called the instantaneous rate of change, which is something that you'll learn to find in calculus. In our current example, the instantaneous rate of change or instantaneous speed would refer to how fast you were driving at any given moment in time. While you were driving, you could determine your instantaneous speed by looking at your speedometer. At any given moment in time, you may be going 60 miles per hour, but you may be going faster or maybe slower. One thing to remember is that when we find average speeds, we're looking at how fast we're going on average over a span of time. But when we find instantaneous speeds, we're looking at how fast we're going at a specific moment in time. Let's now look at what average rates of change mean when we look at graphs. Suppose that we have the following graph for our road trip. We see that on the x-axis, we are measuring the time in terms of hours. In the y-axis, we're measuring the distance traveled in terms of miles. At noon, when our road trip began, we haven't gone anywhere, so our distance traveled is 0. At 1 o'clock, we've traveled 30 miles. At 2 o'clock, we've traveled a total of 85 miles. At 3 o'clock, we've traveled a total of 160 miles. And then at 4 o'clock, we've reached our destination and we've traveled a total of 240 miles. Now let's look at our calculation for the average speed. We took the distance traveled and we divided by the amount of time it took. So 240 miles divided by 4 hours gave us the average speed of 60 miles per hour. But let's look at what these quantities mean in terms of our graph. In our numerator, the 240 miles can be thought of as the vertical distance from the x-axis all the way to our point 4, 240. This green length that I've drawn here has length 240 because that's the y-coordinate of this point. Now, if we look at the denominator of our average speed, we see that we have 4 hours here, and that can be visualized as the horizontal length starting at the origin and going to our point 4, 240. This blue line that we've drawn here has length 4 because that's the x-coordinate of our point. Now, if we look at our graph here and think to ourselves, how do we get from the point 0, 0 to the point 4, 240? Well, the blue length would be the run, or how much I go across, and this green length is the rise, or how much I have to go up. So when we calculated the average speed by doing 240 divided by 4, we're doing rise divided by the run. Now, if you remember, if we do rise divided by run, what we're doing is we're calculating a slope of a line. But the question is, what line are we calculating the slope for? Well, it would have to be the line that goes through the point 0, 0 and 4, 240. So it would be this line here. This line that I've drawn here connecting our two endpoints is called a secant line. And what we see is that the slope of the secant line, which is 240 over 4, rise over run, is the same as the average speed or the average rate of change. Now let's use this idea to help us calculate the average speed not for the entire road trip, but on different time intervals. So instead of looking at the entire road trip, in part A, we want to find what's the average speed between 12 p.m. and 2 p.m. So remember that our average speed is equal to the slope of the secant line connecting the two endpoints. Well, what are my endpoints if we're looking between 12 p.m. and 2 p.m.? At 12 p.m., we're at the point 0, 0, and at 2 p.m., we're at the point 2, 85. So our secant line would be the line that connects those 2 points, which looks something like this. And once again, the slope of the secant line is the average rate of change between 12 p.m. and 2 p.m. So let's figure out the rise and the run for the secant line. The run would be how much we go across, which is 2 units long in our picture, and the rise is how much we go up. Since our point here is 2, 85, we go up 85 units. So our average speed is going to be 85, and since our y-axis is measured in terms of miles, this is 85 miles, divided by 2 hours, since our x-axis is measured in terms of hours. And 85 divided by 2 gives us 42.5 miles per hour. So this is my average speed between 12 p.m. and 2 p.m. Next, let's find the average speed between 3 p.m. and 4 p.m. Again, the average speed is the slope of the secant line connecting 2 points on our graph, specifically the point at 3 p.m. and 4 p.m. At 3 p.m., we're at the point 3, 160, and at 4 p.m. we're at the point 4, 240. The secant line connecting those 2 points would look something like this. If I want to find the slope of the secant line, we would need to find the rise and the run, how much we go across and how much we go up. When we learned about slopes, remember that we can calculate the rise by doing y2 minus y1, and we can calculate the run by doing x2 minus x1. For our 2 points here, y2 minus y1 would be 240 minus 160, which gives us 80. And our run would be x2 minus x1, which is 4 minus 3, which gives us 1. So between 3 p.m. and 4 p.m., our average speed is equal to rise over run, which is 80 miles, divided by 1 hour. That gives me 80 miles per hour. So this is our average speed between 3 p.m. and 4 p.m. So in this video, we learned about the difference between average rates of change and instantaneous rates of change. We also learned that the average rate of change on an interval is the same as the slope of the secant line connecting the two endpoints of the interval. In our next video, we'll learn how to compute the average rate of change for functions over an interval.